Hi. Now I'm understanding that you have got a clear and fair knowledge of how to interface a single switch with Raspberry Pi Pico board. What is the concept of external pull-up resistor? What is the concept of external pull-down resistor? And then we have created this particular code in the last video where we interfaced a single switch. We are using the internal pull-up mechanism, so we are not connecting any external pull-up resistor. A switch is directly connected to pin number 1 GP0 and the second point is connected to ground. This is very simple. All we are doing is we are just making a particular LED go on and off with the switch, and that's all. Now for the next video, what I want you to do is I want to give you a task, or basically let's say two tasks, okay? And now I'm going to write them over here. First task is use two switches. One switch turns on the LED and other one turns off the LED. This is one. And the second one is create an up-down counter using two switches and then print the output using print function. Now let's see how we can go about this exercise. One thing is clear now that just interfacing a single switch will not do for us, and now what we need is multiple switches to be interfaced. So let me just go through my schematic designer. Now if this is how we interfaced one switch, then I guess you would easily be able to guess how we would be interfacing two switches or even more than two switches. It's fairly simple. All you will do is you will simply take another similar switch, or instead I'll simply copy this part here. You can use the same ground connection. I will connect the second switch now to, let's say, pin number GP2. That's all. LED we already have on board. So for two switches, this is all that we need. Let's have this for your reference in the presentation that you are going to get, so that it will be easy for you to understand. So this was a task, but again I'm giving you the schematic for this task over here in the presentation itself. Now let's talk about the code and how will you create a code for this one. Now I'll just close everything else that is needed and we'll open the Thon. So if you remember, this is our previous code where you interfaced a single switch and then you simply used that switch press to display the value, and then we were also displaying it here, and then we are also making the LED go on and off. Now this time we have two switches, so just this declaration needs to be repeated. This time you can't name both of them as switch, so let's call one of them as switch 1, another one as switch 2. One is connected to pin number 0 and another one is connected to pin number 1. Okay. Now what I said is one of them should turn the LED on if pressed, and the other one should turn the LED off if pressed. Now you can try by pausing this video your own particular code, and when you're done you just see how I did it. However, it's not that big of a task to even think of it, but still. So please pause the video and try the code on your own. Now let's look at the solution. What I'll do in while true loop, please understand the purpose of this while true. This is your infinite loop and it must be present for an embedded program. Now I will read the value of switch 1 in a variable called A, and I will be reading the value of switch 2 in a variable, let's say, called B. You can always refer to your code, and you can always write, or you can only write, I would say, another code by looking at your previous code. So if I look at the previous code over here, if A is equal to 0, then we were turning LED on, otherwise we were turning LED off. Now all I need is the same logic here. If the switch is pressed, the value is 0. So if A is equal to 0, what I need to do here is, see, LED dot value 1. Okay, means what? When the switch is pressed, the LED will turn on. That's all. Now, when you want to turn the LED off, you want to turn the LED off when B or switch 2 is pressed. So now, if B equal to 0, then LED dot value 0. So, got it? As simple as that, as easy as that. This is the code that you will be creating for this application. Now let me run this code and let me give it a try if it is working or if it is not. Let me show this to you. The easiest way to show this execution to you is by turning on my camera. I'm not going to use the screen recorder camera because it's just bad. Yeah. Now this looks good. Okay. So this is the Raspberry Pi Pico W board. These are the two switches. This is the common point going to ground over here. This is pin number 1 orange and the gray wire is pin number 2. Now, if you can see now, the LED is, I just made it off. So orange one or the first wire is to turn the LED on. I'll press the switch once, on. I'll press the second switch, off, on, off, on, off. As simple as that. Now, be it using single switch, be it using multiple switch, doesn't matter. You can simply use it as many switch as you want. Now, this is the basic experiment, the LED experiment. Let me save this one for you. So save as this computer, 2 switch and LED. Now what I want to do is, I want to do the second task that was given. What was the second task in the list? Create an up-down counter using 2 switches on PicoW. Print output using print function. Very well, very well. So the structure remains the same. For the up-down counter, you don't need LED. I'll just comment it instead of deleting. And now what you need is a variable. Let's say count equal to 0. Now, when one switch is pressed, you need the count to be incremented. And when the other switch is pressed, you need the count to be decremented and printed on the screen. So what happens here? If switch A is pressed or switch 1 is pressed, count is equal to count plus 1, print count, and here count equal to count minus 1, print count. Now you are going to experience a completely different problem over here. I will just minimize it at one place. Okay. So let's take it here. Let's take it here. The problem that we are going to face here is, see, when I click on the play button, I will press one of the switch. Okay. Let's see what happens when I press one of the switch. I'll press the first switch over here. Okay. Just not stopping, is it? Okay. So it stopped at what? 2551. We wanted to increment it by 1 only, right? I'll just give a short switch press. Just a very, very minute. Still it took 3644. Can you imagine what is happening here? Now what happened or what is happening here is very easy to understand if you just look at it this way. So when you press a switch and when you release a switch, okay, this is the normal switch press. This is a little bit long switch press. This is a short switch press. No matter how you press your switch, okay, is it long or is it short or whatever it is. Let's wait. I just did it 3 times, so I don't know how much it is going to execute. Okay. Now, no matter how long or how short your switch press is or was, the problem lies that you had pressed it at least for several milliseconds. And for those several milliseconds, this if condition was true. And because of the extreme speed with which the Raspberry Pi Pico W is working at, in that several milliseconds, this loop will execute several hundred or even thousand times. And that's why you are looking that when I press the switch, even for, let's say, my shortest time period, it just goes on and on and on. Furthermore, what we can see is the count is incrementing only. That's why we see it in tens of thousands. I'll stop it once and I'll start it. So you can understand what happens the first time I do that. Even if with a short switch press, the count increased to 905. Again, with a very short switch press, the count now increased to something like close to 1800. So this is the problem. And this happens, or this is the problem with every embedded system. So what you need to do is, you need to add some delay after your first switch press. Another problem also happens, which is called as debumps, where the switch contact don't make well, and before completely resting on each other, they do just make break. In that case also, the problem can happen. The simplest solution is, you anticipate how much is the time you keep the switch pressed, and you add that much of delay here. At the max, it's not more than 0.5 seconds. So just add 0.5 seconds of delay here, and I'll add 0.5 seconds of delay here, means half second. Now let's run the code. Now the code is running. Now my finger, first switch, gentle press 1, long press 2 or 3, long press. You can see, if I keep it pressed with half a second's time, the counter is incrementing. So it's under your control. I press second switch, decremented by 1, again once, and just on and on. If I keep the second switch pressed for long, it will go with that delay to 0 and now into the negative domain. So it is important, whenever you are using the switch press for an action, it's imperative that you have to add a debounce delay. You have to anticipate the number of time for which you will keep the switch pressed and add just that much of delay over here. Hope you have understood this, and you will try to create these programs on your own after watching this video. So keep experimenting, stay connected. There will be loads more video with Raspberry Pi Pico W, embedded interfaces and IoT interfaces and so on. Thank you for watching this video.